In today's video, we are going to talk about something really cool known as Pascal's Triangle. Now we are going to be using Pascal's Triangle to expand binomials. So to do things that look like, a plus 5 to the 5th power. Normally to multiply something like that, we would say, okay, I have a plus 5 times a plus 5 times a plus 5 times a plus 5 times a plus 5, right? We would have 5 of them. And then we would have to multiply these two together, and then we'd have to multiply these two together. You have to multiply those answers together, and then you'd have to multiply that answer by this last one, and you'd be here all day, right? And so Pascal's triangle and binomial theorem is something really cool because it takes away a lot of that work and having to be able to do all of those things. So this is Pascal's triangle. And what Pascal's triangle is, it's the coefficients of our binomials. And I'll show you what that means here in a little bit. But what I want to do is show you how Pascal's triangle works. So if we start with this triangle right here, right? We're going to start with 1. Now, if I go down to this box right here, well, there's only one way to get to this box. And so that's how we get the number 1 here. And then over here, there's only one way to get to this box. Let's go to the next row. There's only one way to get to this box here. But to get to this middle box, there are 2 ways of getting there, right? Because you could start at the beginning, and you could go here and then here. Or you could start at the beginning and go here and then here. So because there are 2 different ways to get here, that is why there is a 2 here in the middle. There's only one way to get to this one. Now, if we keep going with this pattern, there is only one way to get to this box, right? That one way would be go here, here, then here, right? I can't go this way to get over there because we're not going sideways. We can only follow these paths. But to get to this box right here, there are 3 ways that I could get to this box because 1 plus 2 is 3. Let's see if we can find those ways. So we could go this way. We could go this way. Or we could go this way. So 3 different ways to get to this box. To get to this box right here, there's going to be 2 plus 1 ways to get there because there are 2 ways to get to this box and only 1 way to get to this box. So 2 plus 1 is 3. And then for this last one, again, there's only 1 way to get there. So basically what you're doing is you're adding the 2 boxes above it to get the next one. So here, there's only 1 box. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And there's only 1 box for this one. For our 5th row, there's only 1 way to get to this box. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 4. And then there's only 1 way to get to this box. And then for our 6th row, there's only 1 way to get to this box. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10, whoops, I made a mistake here. 1 plus 4 is 5. So then 10 plus 5 is 15. 5 plus 1 is 6. And there's only 1 way to get to this box. This pattern can continue on forever, right? You could find the 20th row. You could find the 30th row. You could find the 100th row, right? It's going to take a minute to find it, but we could get there. So this pattern continues on forever. What this does is it tells us the coefficients of our binomial. So if I have a binomial, so remember a binomial is 2 terms. If I have it raised to the 0th power, then my coefficient there would be 1. If I have a binomial raised to the 1st power, then these would be the coefficients of my binomials, of the terms in the binomial. If I have something raised to the 2nd power, then these would be the coefficients. So this represents the 0th power, the 1st power, the 2nd power, and so on. And so this is going to be really useful to us when we go ahead and start multiplying these binomials. And we're doing this using the binomial theorem. So let's read down here. The coefficients of x plus y to the n, so x plus y is a binomial, n is any power that it's raised to, are produced by adding the coefficients of x plus y to the n minus 1 power. So this is saying take your power of n and subtract 1. And if you look here, right, if I'm on the 1st power, then I'm looking at the 2nd row, right? So we call this row 0, row 1. So we're looking really at the 2nd row for the 1st power. And that's all that this is saying right here. It produces an array known as Pascal's Triangle. Pascal's Triangle is a triangular pattern above where each number is the sum of the 2 numbers directly above it, diagonally above it. If there is not a second number diagonally above it, think of it as a 0. So like, for example, this one, we have this number that's diagonally above it, but we don't have another number over here. So that's what you're thinking of as 0. 0 plus 1 is 1. The binomial theorem states that for every positive integer n, you could memorize this rule and you could apply it. The c's and the subsets of c's, so c sub 0, c sub 1, c sub 2, and so on, those represents the coefficients of the binomial. And then a represents the 1st term in the binomial, so if we're looking at this, it would be x. And b represents the 2nd term in the binomial, so in this case, that would be y. And then you'll notice here that here we have a to the power of n. The next term is a to the n minus 1 power times b. And then a to the n minus 2 power times b squared. And then you get all the way till when you have a times b to the n minus 1, and then here to b to the n. So notice that the powers of a decrease while the powers of b increase. And the sum of the powers a and b are always, in each term are always n. So here our power is n minus 1 plus 1 is n minus 2 plus 2 is n, and so on. If your head's kind of like spinning, don't worry, I'm going to break it down so that it's very easy to follow with these examples that we have on the next page. So I have a little image of Pascal's triangle over here for you so you can help visualize what we're doing over here. So it says expand each power. A plus b raised to the 0th power. Well, we learned that anything raised to the 0th power is 1. And that applies to a binomial. But if we look at Pascal's triangle, the coefficient is 1 as well. So we can see that correspond right here in row 0. For a plus b to the power of 1, well, we also know that anything raised to the 1st power is itself. So that's just a plus b. If you want to use Pascal's triangle for that, you can see here the coefficients are 1 and 1. Here the coefficient of a is 1 and the coefficient of b is 1. Now you're like, okay, why do I need to know this Pascal's triangle thing? Let's look at how we would multiply a plus b squared before. So before we knew about Pascal's triangle, if I gave this to you, you would have said, okay, a plus b to the power of 2 means that I have a plus b times a plus b. So let's multiply that. So a plus b times a plus b. A times a is a squared. A times b is ab. B times a is ab. And b times b is b squared. So I would have a squared plus, and then my like terms are ab plus ab, which is 2ab plus b squared. So that's traditionally what you would do to multiply those. Now that we know Pascal's triangle, let me show you how to multiply these using this. My exponent is 2, so I'm going to go to that row. So remember, it's row 0, row 1, row 2. These are my coefficients. So my coefficients are 1, 2, and 1. Because we're adding, we would have addition here. My first term is a. My powers of a need to go from highest to lowest. So because my exponent is 2, that's what I'm going to start with. So these powers of a are going to go 2, 1, 0. My second term is b. So that's going to be next. And for your second term, your exponents go from low to high. So here we are going to go 0, 1, and 2. So now what we are going to do is just figure out what each of these columns are, right? So let's see. Anything raised to the 0th power is 1. 1 times a squared times 1 is a squared. Plus 2 times a times b is 2ab. Brought down that plus sign. Now I'm going to bring down this plus sign. Anything raised to the 0th power is 1. 1 times b squared is b squared. Notice how we get the same answer. So we could have done the area model, or we could have used Pascal's triangle. Now you might be saying, okay, well, why does this work? Why do these represent the coefficients of the binomial? Well, let's see, looking at our area model. How many ways were there to get a squared? Well, the only way to get a squared was by multiplying a by a. How many ways were there to get ab? Well, I could have done a times b to get ab. And I could have also have done b times a to get ab. So there are 2 ways to get ab. So that's why that coefficient is 2, because there were 2 ways on how to get it. How many ways were there to get b squared? Well, there's just 1 way to get b squared. B times b is b squared. That's why that coefficient is 1. So this is how you do it using Pascal's triangle, and that's what we're focusing on in today's class. Now, you might be thinking, well, this way was way faster than this way. Sure, maybe for the exponent of 2, multiplying it out is faster. But what if you had a higher exponent? For example, what if I had a plus b raised to the 3rd power? Well, before today, you would have said, okay, a times b to the 3rd power means I have a times b times a plus b times a plus b times a plus b. So I'm going to begin by multiplying these two together first. And if we look up here, we already did that. A plus B times A plus B is this right here. So I'm just going to go ahead and write that one down. There's no need to re-multiply something that we just did. So when I multiply these two together, I get A squared plus 2AB plus B squared. But I still need to multiply that by this last one. So here I have a trinomial being multiplied by a binomial. So let's go ahead and multiply that out. I'm going to take my binomial and I'm going to write it down the side that has 2. So A plus B. And I'm going to take my trinomial and write it across the top where there's 3. So A squared plus 2AB plus B squared. So let's see. A times A squared is A cubed. A times 2AB is 2A squared B. A times B squared is AB squared. B times A squared is A squared B. B times 2AB is 2AB squared. Or sorry, yep, that's right. And then B times B squared is B cubed. So I have A cubed plus, let's see, A squared B plus 2A squared B is 3A squared B. 2AB squared plus AB squared is 3AB squared. And then B cubed doesn't have a like term. Now that we know Pascal's triangle, right, we can say, all right, if I'm multiplying A plus B to the third power, instead of doing all of this work, I can go, okay, let's go ahead and use this row, because this would be, remember, the 0th row, first row, second row, third row. So I'm going to use this row right here as my coefficients. So my coefficients are 1, 3, 3, and 1. We're adding, we are adding, so that's why I have plus signs here. So our first term is A. So my A's are going to go below each of my coefficients. In your first term, your exponents go from high to low. My highest exponent is 3. So this is going to go 3, 2, 1, 0. My second term is B. And for your second term, your exponents go from low to high. So 0, 1, 2, 3. A quick way to check yourself is that each of these exponents should add to whatever exponent you have to start. So 3 plus 0 is 3, 2 plus 1 is 3, 1 plus 2 is 3, 0 plus 3 is 3. So now I can go ahead and figure out each row. So here's my, or not row, column. So here's my first column. Anything raised to the 0th power is 1. 1 times A cubed times 1 is A cubed. I'm going to bring down my plus sign. 3 times A squared times B to the first is 3A squared B. I'm going to bring down my plus sign. 3 times A to the first times B squared is 3AB squared. I'm going to bring down my plus sign. Anything raised to the 0th power is 1. 1 times B cubed is B cubed. So you can see that we get the same answer. Using the binomial theorem with Pascal's triangle is much more efficient than having to multiply everything out. So let's try these with actual examples. So in example 1, I have a plus 5 raised to the 4th power. So because my exponent is 4, I'm going to this row right here. So remember, over here, this is if I had something raised to the 0th power, 1st power, 2nd power, 3rd power, 4th power. So that's why I'm using this row. So my coefficients are going to be 1, 4, 6, 4, and 1. I'm adding, so I'm going to have a plus sign. So here I'm going to have A, and then my second term is B. Oh, no, sorry, it's not B. Here my second term is 5. So for my first term, A, my exponents go from highest to lowest. So 4, 3, 2, 1, and 0. And then for my second term, my exponents go from low to high, 0, 1, 2, 3, and 4. So now we're going to go ahead and calculate each column. Anything raised to the 0th power is 1. 1 times a to the 4th times 1 is a to the 4th. Bring down my plus sign. 4 times a cubed times 5 is 20a cubed. Bring down my plus sign. 5 squared is 25. Let me grab my calculator. Turn on calculator. There we go. So I'm going to do 25 times 6 is 150. This is going to give me 150a squared. Bring down that plus sign. 5 cubed is 125. So 125 times 4 is 500a. Bring down that plus sign. Anything raised to the 0th power is 1. 1 times 1 times 5 to the 4th power is 625. This right here is my answer. If I didn't have Pascal's triangle, I would have to do a plus 5 times a plus 5 times a plus 5 times a plus 5. I'd have to multiply these two together, and then I would have to multiply these two together, and then I would have to multiply that answer by that answer. So you would be there for a while doing all of that. Because we know Pascal's triangle and we know the binomial theorem, we can get our answer just like this. So let's look at the next one. On example 2, I have 2x minus y raised to the 7th power. Right now, if I look at this Pascal's triangle, I only have up until the 6th power. So I need to calculate the row for the 7th power first. So I'd bring down my 1. 1 plus 6 is 7. 6 plus 15 is 21. 15 plus 20 is 35. 35, 21, 7, and 1. So now that I have my 7th row, I can go ahead and expand this using Pascal's triangle. So I'll have 1, 7, 21, 35, 35, 21, 7, and 1. Here I am subtracting. So you always start with positive. So positive, negative, positive, negative, positive, negative, positive, negative. And then my first term is 2x. Notice how I'm putting it in parentheses. Because my monomial has more than one factor, I need to put it in parentheses for when I go ahead and raise it to a power. So with your first term, you start with your highest exponent and you work your way down. And then our second term is y. And for that one, you start with 0 and you work your way up. Now, one quick way to check yourself while you're doing this is remember your exponent should always add to the original power that you had. So 0 plus 7 is 7, 1 plus 6 is 7, 2 plus 5 is 7, 3 plus 4 is 7, 4 plus 3 is 7, 5 plus 2 is 7, 6 plus 1 is 7, and 7 plus 0 is 7. All right, let's go ahead and calculate this thing. Anything raised to the 0th power is 1. 1 times 2x raised to the 7th. Here I have to use my product property. 2 needs to be raised to the 7th, and x needs to be raised to the 7th. So 2 raised to the 7th power in my calculator is 128 x to the 7th. I'm going to bring down my minus sign. Now I need to calculate this guy. 7 times 2x raised to the 6th. This means 2 raised to the 6th power and x raised to the 6th power. So if you want like a visual of this, whoops, let's do this here. Let me pick a different color. Here I'm doing 7, that's an arrow, 7 times 2 to the 6th times x to the 6th times y. So 2 raised to the 6th power is 64 times 7 is 448. X to the 6th, y to the 1st. I'm going to bring down that plus sign. 21 times 2x raised to the 5th power times y squared. 2 raised to the 5th power is 32 times 21 is 672 x to the 5th y squared. I'm going to bring down that minus sign. 35 times 2x to the 4th times y cubed. 2 raised to the 4th power is 16 times 35 is 560 x to the 4th y cubed. I'm going to bring down that plus sign. 35 times 2x raised to the power of 3 times y to the 4th. 2 cubed is 8. So 8 times 35 is 280. X cubed y to the 4th. I'm going to bring down my minus sign. 21 times 2 squared, which is 4, gives me 84. X squared y to the 5th. I am going to go ahead and bring down my plus sign. 7 times 2x times y to the 6th is 14xy to the 6th. I'm going to go ahead and bring down that minus sign. Anything raised to the 0th power is 1. 1 times y to the 7th is y to the 7th. This entire thing right here is my answer. And don't worry, it's already written in standard form for you. It's a lot faster than having to multiply this out 7 times. My trick to you is going to be to try to stay organized while you're doing this. If different colors helps you, great. If the columns help you, great. If you'd rather write it out all as one as you're going, awesome. Just be mindful of how much space you have on a page. Let's look at example 3. Example 3 says find the coefficient. So I don't have to multiply everything out. We just want to find the coefficient of y cubed x cubed in the expansion of y plus x raised to the 6th power. So if I have y plus x raised to the 6th power, then I'm going to be looking at this row right here. So I have 1, 6, 15, 20. Let's see. 1, 6, 15, 20, 15, 6, and 1. My first term is y, so I'm going to go from my highest exponent to my lowest exponent with my y's. Whoops. And then my second term is x, and so those exponents are going to go from low to high. All right, we want to find the coefficient of x cubed, y cubed. Well, x cubed, y cubed is going to be this row right here. 20x cubed, y cubed, or 20y cubed, x cubed, the coefficient is 20. And so my answer is just 20. All they wanted to know was the coefficient, the number out in front. Now, it won't always be the number that's up here. Right, if you have numbers inside of here that you're doing to multiply, then that will change what your coefficient is. But you would just multiply this column together and figure out the number that's the coefficient. So let's see what that looks like on example 4. So on example 4, it says find the third term of 3x minus y raised to the 5th power. So if my exponent is 5, then that means that I am looking at this row right here. So the coefficients in that row are 1, 5, 10, 10, 5, and 1. Let me just double check. That's right. All right, so I want to know the third term, right? Let's see, positive, negative, positive, negative, positive, negative. So the third term is going to be right here. So my x's are going to go, so 3x I should say, is going to go from high to low. Now if you wanted to, you could keep going over here, but you know that you only need this row. So I'm just going until I figure out what this row is. And my second term is y, so those ones are going to go from low to high. And let's go ahead and figure out this third term. So 10 times 3x cubed. Remember, 3x cubed means that I would have, let me write this out for you. There we go. So if I'm calculating this column here, I have 10 times 3x cubed means I have 3 cubed times x cubed times y squared. 3 cubed is 27. 10 times 27 is 270, x cubed, y squared. Here they didn't ask for the coefficient. Here they asked for the term. So the term is 270 x cubed, y squared. If they said find the coefficient of the third term, then the coefficient would be 270.